When most people hear the term climate change, images of environmental degradation, pollution, and rising sea levels come to mind. One interesting way to combat these adverse effects of climate change is actually through technology. Geoengineering is the deliberate, large-scale manipulation of an environmental process that affects the Earth's climate in an attempt to counteract the effects of global warming. There are many different types of geoengineering, but the one I will focus on today is called solar radiation management. This technique involves reflecting some of the sun's radiation back into space to counteract rising temperatures from anthropogenic greenhouse gas emissions. A proposed method to achieve this involves injecting sulfate aerosols into the atmosphere with planes or high-altitude balloons to help cool the planet. Sulfate particles reflect shortwave radiation, but tend to absorb long-wave radiation. This would result in a warmer stratosphere, but overall cooler surface temperatures. This concept can be illustrated with simple physics and a layered model of the atmosphere. Incoming shortwave radiation from the sun penetrates the top of the atmosphere and eventually reaches the Earth's surface. This is regulated by the Earth's albedo, which is a measure of how reflective the surface is. Once the incoming radiation reaches the Earth's surface, it is absorbed and re-emitted as long-wave terrestrial radiation. This long-wave radiation travels back up through the atmosphere and is absorbed and re-emitted at different layers. This greenhouse effect warms the surface because the atmosphere is mostly transparent to solar radiation, but readily absorbs terrestrial radiation. However, if sulfate aerosols are injected into the stratosphere, they dramatically increase the Earth's albedo, or reflectiveness. This results in less shortwave solar radiation reaching the Earth's surface in the first place, in turn cooling the planet. Overall, this would reduce the radiative balance of the Earth and decrease temperatures around the world. Violent volcanic eruptions are natural processes that show evidence of this. When they erupt, volcanoes with high sulfur gas contents shoot aerosols high into the stratosphere, where they remain for many months or even years. One of the largest modern volcanic eruptions occurred in the Philippines in June of 1991. Mount Pinatubo exploded in a cataclysmic eruption that injected 20 million tons of sulfur dioxide into the stratosphere. Dispersal of this gas cloud around the world caused global temperatures to drop by about 1 degree Fahrenheit for over 3 years. This illustrates the powerful impact that sulfur aerosols can have in regulating the Earth's climate. Using these sulfate aerosols to offset global warming is appealing because the physics and cost of doing so indicate it would work. However, critics argue that it would have many unintended consequences and fail to address the underlying problems of climate change. If sulfate aerosol injection were unregulated, it could potentially cool the climate too much. This could result in massive crop failures around the world because of decreased temperatures and potentially altered monsoon patterns. High sulfate concentrations in the atmosphere could also lead to increased acid rain, changes in ocean circulation, and continued ocean acidification. Although the sulfate aerosols would mitigate sea level rise and increase temperatures from climate change, they would have to be continually ejected into the stratosphere to prevent temperatures from rising again. This could lessen the incentive for people to reduce emissions and move towards clean energy alternatives. Overall, combating climate change with solar radiation management is like taking a Tylenol to combat a bacterial infection. It provides temporary relief, but does nothing to solve the underlying problem. Geoengineering is a useful Plan B option for addressing climate change, but should not be prioritized above emission reduction strategies. Solar radiation management is an interesting concept, and with further research may play a part in our planet's future.